Solve the triangles given angle A equals 29 degrees, A equals 8, and B equals 12.5. I'm going to draw a little sketch first. I'm going to label this angle A. So this will be side A equals 8. And this will be side B equals 12.5. And this will be the height right here. Now the first thing I need to do is determine how many triangles can be formed. And you do this by calculating the height of the triangle. H equals B sine of A, which equals 12.5 sine of 29 degrees. We'll get the calculator. So make sure that you're in degree mode, otherwise your calculations will be way off. So 12.5 times the sine of 29 degrees, 6.06 is the height. Okay, so 6.06, and since the height is shorter than A, which is shorter than B, we can have two possible triangles. One would be the triangle that you see, and the other one would be like that. But we'll get to that in just a minute. First, I'm going to use the law of sines to solve for the first triangle. I'll have this be angle B, and this one be angle C. So sine of 29 degrees to A, which is 8, equals sine of capital B over 12.5 equals sine of angle C over side C. Okay, so that's the law of sines, and we have three items left to solve for to solve the first triangle: angle B, angle C, and side C. Okay, let's solve for angle B first. Cross multiply this proportion, and it's going to be 12.5 times the sine of 29 degrees equals 8 sine of B. So then divide both sides by 8, and 12.5 sine of 29 degrees divided by 8 equals sine of B. Now I'm going to go to the calculator. Okay, so this means that the sine of angle B is 0.757515, so on and so forth. But I want to find the measure of angle B, so I'm going to do the inverse sine of that value, which I'm going to get from the answer button. Okay, and there's our angle B, 49.2 degrees. So I'm just going to write the values up here. B equals 49.2 degrees. And now to find the measure of angle C, all we need to do is use the Triangle Sum Theorem. So basically it's going to be 180 degrees minus 29 degrees minus 49.2 degrees equals C. So you have your 180 degrees, you subtract the other two angles, that leaves you with angle C. So let's figure that out. 180 minus 29 minus 49.2, 101.8. So C equals 101.8 degrees. So the last thing to solve for is the side length C, and I'm going to use this proportion. I'm going to go all the way across, just like that. So I'm going to ignore the middle part of this proportion and just use the two ends. So cross multiplying, it's going to be 8 times the sine of C, and we know the measure of angle C is 101.8 degrees, equals C times the sine of 29 degrees. Divide both sides by the sine of 29 degrees. So side C is going to equal this calculation here. So let's take a look. 8 times the sine of 101.8 divided by sine of 29 degrees. 16.15, I'll just say 16.2. Okay, so this part here is for the first triangle. Now we're going to solve for the second triangle. So the way you do that, let me go ahead and draw it first. So this is going to be like the B2 right here. So we know that the measure of B1, I'll make this B1 just so you can tell the difference, was 49.2 degrees. And that means this angle over here is going to be the same measure, 49.2 degrees. And that's because this triangle B1, B2, C is isosceles. So knowing that, I can say that this angle is 180 minus 49.2 degrees, and that's the measure of angle B2. So that's 130.8 degrees. So I'll just put a B up here, equals 130.8 degrees. So then what I can do is I can apply the triangle sum theorem in this situation. So it'll be 180 degrees minus my 29 degrees for angle A, and then minus the 130.8 for this angle B, and that'll equal angle C. .2 degrees. Okay, last item to solve for is the other side C, and we use the law of sines for that. So it's going to be sine of 29 degrees to 8 equals sine of 20.2 degrees to side C. Now we'll cross multiply that, and it's going to be 8 times sine of 20.2 degrees equals C times the sine of 29 degrees. Divide by the sine of 29 degrees. So angle C is going to be this calculation, 8 sine of 20.2 degrees divided by sine of 29 degrees. So rounds to 5.7. So that's the complete process for solving for two triangles using the law of sines for a side-side angle situation. You solve for the first triangle using the law of sines and the triangle sum theorem, and then you do the same thing for the second triangle. Go ahead and figure out what the new angle has to be right here, this B2, and then you use the triangle sum theorem and the law of sines to solve for that one. Just take it one step at a time and be careful with your rounding, because if you round too much, your answers are going to be farther off.